Alright, today I'm going to do chapter 15.3, rates of change. I give you two examples here just to illustrate the idea of rates of change. First, I give you an example, this one. If x represents the distance traveled by the object in t seconds, okay, so they give you x equals to 3t squared plus 5t. Then if I differentiate x with respect to t, okay, I get 6t plus 5. What this differential represents is the rate of change of x, okay, per unit time. Okay, what's the rate of change of x per unit time? So basically, right, if x is distance per unit time, okay, what we're actually talking about here in reality is the speed. Okay, another example of this is, let's say r represents the radius of a spherical balloon. Okay, as you blow the balloon gets bigger and bigger. Okay, so radius is 4t squared plus 3t. This is just a fake example. So when I differentiate r with respect to t, you get 8t plus 3. What does this actually represent, right, is the rate of change of the radius. So that means, right, this one represents, right, at any given time, right, how fast, okay, so how fast is the radius changing. Similarly, the speed here, right, is how fast is the distance changing. So that's the idea behind the rate of change. So when you differentiate, right, x per unit with respect to t, or respect to t, right, you get the rate of change of how fast is x changing, how fast is r changing. So that's the main idea behind rates of change. So now I'll just give you one simple example from this exercise 15.3. I'll do question 4. Okay, question 4 works like this. The radius of a spherical balloon, right, is given by r equals to 3 plus 2 over 1 plus t. First question, part 1, what's the initial radius? Okay, initial radius, okay, it means that initially, for initial radius, the time is equals to 0. Nothing to do with differentiation yet. So r equals to 3 plus 2, 1 plus 0. So in the end, my initial radius is 5 cm. Simple enough for part 1. Okay, now we move on to part 2. Okay, part 2 works like this. Find the rate of change of r with respect to t when t equals to 3. So, rate of change of r with respect to t. So first I rewrite my r to 1 plus t to the power of -1. Rate of change of r with respect to time. So I differentiate. 3 you differentiate get 0. So you get -2. 1 plus t to the power of -2. So what they actually want me to find is the rate of change of r with respect to time when t equals to 3. So I get -2, 1 plus 3 square equals to -2 over 4 square is 16. Alright, there is -1 over 8. Okay, what is cm per second? Alright, so you notice, right, that my radius is actually decreasing by 1/8 of a cm per second when the time is equals to 3 seconds. So they suggest what may be happening to a balloon in this second. So what is one reason for the radius of a balloon to be decreasing? Well, I suppose, right, the balloon was deflating. Hence, at that moment in time, okay, the balloon is actually becoming smaller, hence the radius is becoming smaller. That's why the radius is decreasing at 1/8 for cm per second at the instant of time when t equals to 3. And that concludes my examples for 15.3 rates of change.